All right, ladies and gentlemen, today we're going to review parallel lines and transversals and their relationships and the angles that they create when we have this. This should be an im2 review, so you should have seen this before. If not, hopefully this helps you out. So, the definition of a transversal is the following. It is a line that intersects or crosses, either word works, they mean the same thing, two coplanar lines. So an example of that is this diagram here. Line T is my transversal. These are the lines A and line B that are being intersected or being crossed by my transversal. Okay? When this happens and you have a transversal situation, it creates an exterior part. So exterior part are going to be on the outside of the lines being crossed. Okay, so the exterior again are on the outside of the two lines. The interior are in between the two lines being crossed. So exterior, interior. Okay, so in this diagram over here, we are going to answer questions A and B. So the first thing you want to notice is that my transversal is this line here, or this arrow here. This is a transversal because it's crossing two other lines. And what you'll notice is these numbers labeled here represent angles. So if you look, there's 4 angles created here. There's 4 angles created here, and they're labeled with numbers. So in the question A, it says, which angles are in the interior? So the angles on the inside are the inside of the two lines that are being crossed. So if you look, we have these two lines. The angles that are inside the two lines are 2, 6, 7, and 8. So angle 2, angle 6, angle 7, and angle 4. So I think I said that incorrectly. It's 2, 6, 7, and 4 are the interior angles. Okay? The exterior would be 8, 3, 1, and 5. These would be exterior angles. All right, problem B, which angles are on the same side as angle 7? So we look at angle 7. Now when we talk about same side, we want to talk about the same side of the transversal. So our transversal is this arrow. So which angles are on the same side as 7? So the answer to that would be 8, 2, and 1, because they're both, all 3 of them are above the transversal, and angle 7 is also above the transversal. So 8, 7, 2, and 1 are all on the same side. So angle 8, angle 2, and angle 1. The next thing we have to talk about is parallel lines. This is going to play a big role in what we're learning today and what you should have learned in im2. So by definition, parallel lines have the same slope. That just simply means they're going in the same direction. Okay? They also, by definition, will have different y-intercepts. So that means that's just trying to tell you that they're going to be different lines. They're not going to be the same line, but they're going to be going in the same direction. The symbol for parallel lines in geometry is 2 vertical lines like we have here. So this is their symbol. Here's an example of vertical lines. Parallel lines. Line L and line M are parallel to each other. Okay. These little arrows here, because they're in the middle of the line, these little symbols, these triangles, let you know that these lines are parallel. So when you see these little triangles, it's telling you that these two lines are parallel to each other. That means they have the same slope. They go in the same direction. They will never intersect. Okay? So it's important to understand that. Parallel lines never intersect. Never intersect or never cross. All right? So, real quick, in geometry we use this symbol again. This is parallel line. So this sentence right here, L parallel M, okay, would be read as line L is parallel to line M. So instead of writing all this out in geometry, we can use this to symbolize this sentence. Okay. In Google Classroom, I want you to give your example of a real life parallel line, okay, or something that you know is parallel in real life. I want you to put that in the comments in Google Classroom. Now we're going to review angle pair relationships. So as you can see, we got 5 diagrams in here of different angle pair relationships that we're going to talk about. So let's start with what makes the parallel lines special in a transversal angle pair relationship. So up here it says if lines L and M, so if you notice all these are L and M lines, if lines L and M are parallel, something special happens. Then the following examples are true. Okay? So in number 1, we have a relationship called corresponding angles. So angle 1 and angle 2 are corresponding. Here's my transversal. Here's my parallel lines. And what's special about corresponding angle, if these lines are parallel, then corresponding angles are congruent, which means they have the same measure. They'll be the equal degrees. Okay, so equal degrees, that's the same as congruent. All right, and we'll get into corresponding angles. The best way to think about corresponding is that they match each other. So angle 1 and angle 2 are simply matching. Angle 2 can move and it can replace angle 1. That's corresponding. Corresponding means matching. Okay. Situation 2. We have alternate interior angles, which you probably were taught as AIA. When you have parallel lines again, angle 3 and angle 4 are interior, and they are alternating. They go on different sides of my transversal. When this happens, angle 3 and angle 4 are alternate interior angles, and they too will be congruent. Okay. The next one is alternate exterior angles here. So now we're looking at the outside angles, and again, outside from the parallel lines. So here's my parallel lines. The angles are on the outside. So angle 5 and angle 6 are on the outside, and they alternate across the transversal. So they are on different sides of the transversal. One's on the right side, one angle's on the left side. That is alternating. They're in the outside exterior, and they are the angles. So 5 and 6 are alternate exterior angles, and these two are also congruent. Okay, and then the last relationship. So now we're looking at same side interior angles. So interior means inside, and so we're looking at angles on the inside of the parallel lines and on the same side of my transversal. So if you look, 7 and 8 are on the inside, and they are both on the right side of my transversal. When you have same side interior angles, These are supplementary angles. And supplementary simply means they add up to 180 degrees. So in other words, angle 7 plus angle 8 should equal 180 degrees. In this diagram, it's a extension diagram. These type of angles here, angle 9 and 10, if you notice, one is on the outside, one is on the inside, and they're both alternating. These type of angles have no relationship. Okay? So non-example angles are not related in any way. They're not equal to 180. They do not add up to 180. They are not congruent to each other. Okay? So you just have to be careful here. So to make sure that we know what we're doing. Okay, so hopefully all that information kind of refreshes your memory of im1 and transversals and parallel lines. So we're going to go ahead and do this example. If you want to pause the video to try it first, go ahead. But let's go ahead and start doing this. First thing I notice in my diagram is I have a transversal. So T is my transversal, and I'm going to put him in red because he's a special line. Let's make this a little better. That's not much better. One more time. Okay, so there's my transversal, and he's a transversal because he's crossing two other lines. Okay, I also know the two other lines that he's crossing are called L and M, and because of this symbol here, these little dark arrows or triangles, I know L and M are parallel. So I'm going to write that down just as a note. L is parallel to M. Okay? So that's when I see parallel in a transversal, I can start thinking about all the relationships we talked about in the previous slide. So if you look here, the only angle I know is that this angle here is 110 degrees. So I'm going to highlight him in blue. Okay? So I want to use 110 degrees, and I want to solve for angle 2. So 110 and angle 2. What you should notice is 110 and angle 2, this relationship here is called a linear pair. And linear pairs add up and equal to 180 degrees. Okay? So if this is 110 with angle 2, I need to figure out what's left over of 180. So angle 2 has to be 70 degrees. Because 110 plus 70 together, when you add them up, equal 180. And that's the definition of a linear pair. Okay, so angle 2 is 70 because of linear pair. All right. All right, so now we're going to go ahead and look for angle 7, the measure of angle 7. So what you should notice here, again, I'm going to highlight angle 110. We're going to use angle 110 to find angle 7. And what you should notice is that angle 110 and angle 7 are on the outside of the parallel line, so they are exterior angles. Angle 110 is on the left side of the transversal. Angle 7 is on the right side, so they are alternating sides. So this is alternate exterior angles, and because these are parallel, we know alternate exterior angles are congruent. So 110 and angle 7 have the same measure. So we can now say angle 7 is 110 degrees by alternate exterior angles. Next one, angle 5. So this is equal to 110. This one is equal to 70. I'll keep these in there. Okay, angle 5 now. This is from a previous example. Okay, so angle 5 and angle 7, since we know angle 7, we can say these are vertical angles, and vertical angles are congruent. So 5 and 7 will be vertical angles. But using one of the relationships in the last slide, with angle 110, angle 5, these are corresponding angles, because if you can move 5 to 110, they're essentially the same angle, just in a different location. And that's the definition of corresponding. It's basically the same angle, just in a different location. So angle 5 is also equal to 110. And this is by using the relationships previously. This is by corresponding angle. Corresponding means the same. All right, now we're going to measure angle 3. So using angle 3 with 110, these again are vertical angles. So angle 3 is the same measure as 110 because these are vertical angles. So this is equal to 110. And I used vertical angles. And then last but not least, measure angle 6. There's many ways to find the measure of angle 6, but I'm going to use same side interior angle. So if you look, we're using 3 and 6, and we know 3 is 110. So same side, which means transversals. These two angles are on the same side. They're both on the right side of the transversal. They're on the inside of the parallel lines. So these are same side interior angles, and we know same side interior angles add up to 180. So that means angle 6 plus angle 3 should equal 180, and we know angle 3 is 110. So 110 plus angle 6 should equal 180, which means angle 6 must be 70. And we used same side interior angles. So again, this should be reviewed, and hopefully you're getting a little more comfortable with transversals and parallel lines.